Welcome to this explainer. Today, we're diving headfirst into the heavy-duty world of industrial machinery. We are going to track the fascinating life cycle of how raw, unyielding steel is transformed into a high-powered vertical baling press, manufactured right by Rotec Vietnam. If you've ever wondered how heavy industry actually builds its solutions from the ground up to handle just massive amounts of scrap and cardboard, well, you're in exactly the right place. We're going to look closely at the design, the structural welding, the entire manufacturing process, the painting, all the way to the final operation and handover. Let's jump right in.
So I want you to imagine a massive manufacturing facility for a second. Think about the sheer volume of byproducts they generate every single day. We are talking actual mountains of cardboard, huge piles of scrap fabric, endless heaps of discarded packaging. You know, unmanaged industrial waste is an absolute logistical nightmare. It eats up incredibly valuable floor space, it creates severe safety hazards, and transporting it in its loose, bulky form, that costs an absolute fortune. So how do you deal with such massive physical chaos? How on earth do you tame the mountain?
So, the crucial point is the staggering physical and financial difference between these two states. Notice the chaotic, sprawling nature of loose scrap. That represents a massive drain on operational efficiency. Every cubic meter of trapped air in a pile of garbage is literally money wasted on storage and shipping. But compare that to the alternative. Compact, dense bales. Organized, highly efficient, and completely ready for transport. The Rotec baling machine basically acts as the bridge between these two realities, serving as the definitive solution for modern waste management.
Okay, let's dive into this. To understand how we actually get those perfect bales, we have to start on the factory floor. Notice the raw, unpainted, heavy-duty welded steel frame of the vertical press. This isn't just bolting some metal together. It is serious, heavy-duty structural engineering. From the very first weld, these frames are designed to be incredibly robust. Notice the thick steel columns and the heavy reinforcement all around the compression chamber. That thickness isn't random. It's heavily engineered to prevent metal fatigue over years and years of repeated, intense stress. The entire integrity of the final machine relies completely on the precision and strength of this initial structural welding phase.
And you might be wondering, why does the structural design need to be so over-engineered? Well, it's because of this force requirement: 80 tons. That is an immense, almost unimaginable amount of pressure. This raw frame must be structurally sound enough to withstand up to 80 tons of hydraulic pressing force. Heavy-duty models produced by Rotec push against those steel walls with incredible force to crush industrial waste like heavy scrap and dense cardboard. If the structural design and those welds aren't absolutely flawless, the machine would quite literally tear itself apart under its own power. Because of that, the manufacturing journey follows a very strict, highly controlled progression. Step 1 is that structural welding we just talked about, establishing the unbreakable core. Step 2 is finishing and painting. And you know, this isn't just about making it look nice. Industrial-grade paint protects the steel from corrosion, rust, and the really harsh environments of waste processing facilities. Finally, Step 3 is electrical integration. This is where the machine gets its brain. The heavy-duty hydraulic pumps, the control panels, the safety sensors, they're all wired into the finished frame, transforming it from a static heavy metal structure into a dynamic, fully automated system. And this brilliantly illustrates the culmination of that whole manufacturing process, the final polished machine. The contrast from the raw steel is just striking, isn't it? Notice the vibrant blue and yellow paint. In an industrial setting, those high-visibility colors are absolutely critical safety markers, indicating a fully finished, safety-compliant piece of heavy machinery that's ready for intense daily operation. You can clearly see the integrated electrical control panel right on the side, complete with operational buttons and warning lights. It brings all that 80-ton hydraulic power right to the operator's fingertips.
Once this machine is deployed, its versatility is truly remarkable. I mean, these balers are definitely not one-trick ponies. Based on Rotec's design specs, they effortlessly crush and compress a massive variety of materials. We're talking mountains of cardboard and paper from logistics hubs, scrap fabric from the textile industry, general bulky industrial waste. They even design specific configurations for recycling aluminum cans or destroying and compressing expired milk cartons in liquid packaging. It's essentially a universal solution for compressing physical volume. To truly grasp the sheer scale of the output, keep this number in mind: 400 kilograms. Depending on the exact model and the material being processed, these machines take that chaotic, loose, bulky waste and compress it into incredibly dense, solid geometric bales that can weigh up to 400 kilos each.
Think about the logistical efficiency of moving neat 400-kilo blocks with a forklift compared to, say, shoveling tons of loose, blowing paper scrap into a truck. It is a total game changer for facility management.
Now, what's really interesting about this is how they scale to a facility's needs. Rotec basically provides two core options. We have the vertical baler, which we focused on during the manufacturing phase. It's generally semi-automatic, and it's perfect for facilities dealing with moderate volumes of cardboard, paper, or fabric, where an operator just loads the material vertically. But for massive, large-scale industrial operations, they build the horizontal baler. These things are fully automatic beasts, capable of continuously churning out those massive 400-kilogram bales of heavy industrial waste without even stopping.
But before the machine starts doing the heavy lifting for the end user, it goes through a seriously rigorous handover sequence. Week 1 involves intense final testing of all the hydraulics and safety systems. Week 2 brings in client acceptance, where the buyer actually verifies the machine's performance against their own specific materials. Only then do we reach Week 3, the formal global handover, ensuring the operators are fully, properly trained. By Week 4, that machine is fully integrated into daily operation, flawlessly doing its job.
And you know, that meticulous attention to detail, from the very first weld to the final handover, has built a massive international footprint. Rotec Vietnam's engineering is trusted globally. These machines are deployed not just domestically in Vietnam, they are highly sought after by really demanding industrial clients in Japan, South Korea, Thailand, and Hong Kong. It's a huge testament to the fact that effective, robustly engineered waste management solutions are a universal industrial need. They cross borders to solve real-world environmental and logistical challenges everywhere.
Which brings us to the final thought I want to leave you with today. Look at your own operations, or just consider the global industrial landscape as a whole. How much space, how much energy, and how much logistics cost could be saved by aggressively compressing our waste footprint? The technology, forged from raw steel and 80 tons of hydraulic pressure, it clearly exists to tame the chaos. So the real question is, how quickly will the rest of the industrial world adapt to this incredible level of efficiency? Thank you so much for joining me for this explainer. Keep asking great questions, and I'll